and especially the ones where I actually like stayed for the whole talk. This has been really awesome. So like Paul Milson, I don't know if you caught that just now, but that was a pretty awesome talk. We had him in here today. I don't know if any of you were in here earlier, where we had people sitting on the floor. So I mean, it's just been a really good day, and really happy that y'all could be a part of it. Got a T-shirt to give away. First person to raise their hand and tell me who sponsored the CTF. Right here.
He's going to be keeping time.
Oh, you gotta pronounce it right. Okay. And then, let me think of a good one. Which sponsor gave away the little stuffed onions? Right. All right, here we go. Ready? Yeah. All right. Alpha Networks card. Okay, so we saved the best last here in this track. So I have for you John Creekmore and Michael Edie. Go for it, guys.
All right, thanks, Phil. Phil works really hard, everybody, with a lot of things here. So, BSides board, or ISSA, security onion solutions, and a lot of things in the community, just as a person here. So, thanks, Phil. So, my name is John Creekmore. This is Michael Edie. He's my co-presenter. We're going to be talking today about hide and seek with EMET. So, this is a defensive track talk, for the most part, if anybody hasn't seen that yet coming. We're going to talk a little bit more today about the Enhanced Mitigation Experience Toolkit. So this is a free solution that Microsoft has. They've had it for several years now. A lot of people have it in their environments. By show of hands, how many people have actually deployed this tool before? Okay, so how many people feel that they are pretty comfortable with using this tool? Okay, cool. Couple hands. And then another thing, how many people feel they really know this tool? Okay. Oh, good. Very good. Nice. Nice. A lot of people, it's one of those things, it seems like Mike and I talked about it, where there's a lot of times people are using EMET, but they don't really understand fully how it's deployed, how to control it, how to manage it, and how to push it through their environments. So this is our agenda today. We're going to talk about pretty much the overview of EMET, what it can do for us. We're going to go into using it in defensive security. Historical issues, we're going to talk a little bit of some of the flaws in the past that EMET's had, and a myriad of things that Microsoft has done to try to keep it going. It is a free tool. It's not something that, there's a great amount of resources and budgets going into it. If you know how to use it right, it's a very good solution that they provide you for free. And MSRC, the Microsoft Security Research Center, is doing a great amount of things right now to push it forward. Because as many people know, we're looking at some next generation Windows stuff coming out of the woodworks, and .NET Core is going open source. There's a lot of things going on right now with Windows, making it more interoperable, cross-platform compliant, and further server core coming out. So a lot of people are thinking, what are we doing moving forward to maintain this tool? And then Michael's going to give pretty much the demo, where he's going to break everything down, show you some things about EMET, show you that it works, show you that it doesn't sometimes, and obviously how to use it more effectively. And then we'll go into discussion and questions quickly. Okay, that's $20 worth of metrics. No, that's not, because while this is up here, you're not going to get this all in a day. There's a lot of things to use EMET for. People think that this is one of those tools where you can just very quickly quantify your return on investment for using it. You won't, but absolutely for coming here today, we hope that you're going to go back and have a game plan for how you're going to use this more effectively, as well as if you do have an environment where you train others, train them as well. Thanks. All right, so I don't really have cool handles. Recently, Mr. Reboots, a nickname I got from a lot of people. A little bit about me. So before coming here, I was in Seattle. Used to spend a lot of time with the .NET developer guys out there out of Redmond. So they're a really good community. If you ever get the chance to actually head out to Redmond, Bellevue, Washington, stop by some of their meetings. They have like meetups and stuff. A couple hundred developers get together and really just hash out a lot of things. The college is cool. I do a lot of things with charities for the most part. And they got some professional cool stuff that I've done. And right now I'm working as a Chief Security Officer, Director of Information Technology on a board for a venture capital. So next.
All right, so that's a little bit about me. You can read the slides. It's pretty self-explanatory. If you haven't heard of Smash the Stack, it's basically a vulnerability network. You can go in there and do war games. So buffer overflows, all the different vulnerabilities you can think about, format strings, off by ones, you name it. We also have web app pen testing, and we have an IRC channel. So most of you have heard of it. If you haven't, go to smashstack.org. check it out. And that's me.
All right, so we're going to break into defining a little bit more about EMET, explaining it better in detail. So what it is and why you should care. Thanks. All right, so basically looking back, the Enhanced Mitigation Experience Toolkit, one of the things about this is a lot of people don't really understand what it's intended for Microsoft officially. Originally, EMET was brought forward to the front so that way we could actually maintain a lot of legacy applications. Out there in the wild, a lot of people running older server editions, they have applications that are proprietary, third-party. Then you have to maintain them. It's not as simple as saying, hey, I'm going to go ahead and update my operating system, patch everything forward on Tuesday, and hey, we're good to go. There was a lot of issues that we could not just maintain moving forward, especially with the jump to 64-bit application architectures. So Microsoft Security Research Center was saying, hey, what can we do to try to bring some of the software patching? I don't want to say necessarily that it's patching per se, but it was the mentality of say, okay, what can we do still in legacy systems to protect against advanced memory exploits and vulnerabilities out there. So they came up with EMET for that purpose. And it's free, still maintained, as we stated. Mitigates vulnerabilities in software, so software flaw vulnerabilities, memory leak protection. We're going to break into that slide later on here in a little bit and explain more about the actual security controls for it. And then cyber attacks targeting memory corruption. So a lot of things working with ROT attacks, so return-oriented programming and all. We'll discuss that farther next. All right, so command line. So EMET has a command line for a lot of people who like to administrate the command line. That's up to you. There's different things that you need to know about working with the command line, of course. It does have a GUI. For the most part, how many people have actually worked with the EMET GUI? Okay, cool. How many people work with the EMET command line? Really? Oh, okay, well, no, that's good. That's good. Hopefully share that with some of these folks. It's quicker. If you know what you're doing with it, it's really rapid to deploy it. Michael will show that in his demo. And also change your configurations really easy to manage there in the command line too. And it can aid in detecting targeted attacks. A lot of people don't really use EMET at the cyber intelligence level, layer 8 of the OSI, right? When you talk about EMET, you have granular control, so you can actually break down every single process control, memory protection control that they have that EMET can do for these DLLs and all these processes. So when you use that effectively, that can help aid you, right? So we're talking about, hey, maybe I want to see if my browsers are having certain types of attacks happening with memory protection things, right? So you can go in there, you can turn it on, you can turn it off, and then that can help you with troubleshooting. But you can take it another step forward, and with EMET, you can actually control how certain applications are going to utilize EMET's functions. And then heavy on memory protection, but also SSL pinning. So yeah, SSL pinning is one of the things that people don't really dive into. Has anybody actually used it? Like really, like this has saved my environment? Yeah, oh, let's be fair as well here, right? So SSL pinning, Microsoft digitally certified websites. How many is there? Explicitly, Microsoft has several. It's not very large though. It's very low quantity of pre-certified websites. You can work with getting more in there, but it's really just something they're working actively on right now, building into that function. So next slide, please. All right, so this is a breakdown. This came from Krebs on security because Brian Krebs knows your memory more than you do, and that's really cool. But anyways, this is actually the breakdown of all mitigation efforts that EMET works towards. These are all the different types of memory controls and protections, and every one of these is able to be turned off and turned on. Some of the more common ones that you're going to probably talk about today in the demo is working with everything that works with return-oriented programming. So breaking that down, return-oriented programming is going to look a lot at stack pivots, execution flow, where things are getting called in from, so the caller checks, memory protection functions to make sure that we're not executing things from areas of memory that's not supposed to be marked as read-write, maybe it's only read-only, what's going on with that. So we're not going to kill that. Next slide. That's all on Microsoft's official documentation, by the way. All right, so using EMET with defenses. So how are we going to actually get into talking about this? So what cyber protection does it provide? 32-bit legacy applications that were older. We covered this already a bit. Apps compiled with older compilers. This is very common. So Michael works a lot with compiling, and he knows more than I do about this, to be fair. But in the .NET world, as a .NET coder, how many .NET programmers in the room? One or two? Okay, well, great. Awesome. Stand up. Yeah, get excited. Hey, so we're very visual people. We work a lot in the IDE, like, hey, Visual Studio, hey. Wow, Microsoft, this is why we have conferences called that. So no, really though, the thing about it is we've been very dependent on allowing these IDEs to, pretty much automate the compiling process for years for us. So a lot of people that are out in the wild developing applications, they don't really get deep into understanding the compilation process. The just-in-time compiler, everything else does a lot for us. We really focus a little bit more on the programming logic of our applications and features that they provide to the end user. So a lot of the older compilers are compiling, all these applications, they don't have certain protection functions enabled yet. For example, it's very common moving into about the time where we have 64-bit coming around the market. So people still use these every day. I don't know, I've done this job for 10 years and, we still have applications that are being pushed out now that are 32-bit, even today, and they don't have a data execution provision included. So Microsoft and non-Microsoft software, that's a big thing. It doesn't have to be enterprise class protections. It will absolutely work to protect 32-bit applications as well as 64-bit that are third-party. But you need to be cognizant of understanding that Microsoft can't absolutely say what third-party apps are going to do for you. It may actually cause conflicts functionally. So it may crash them, trying to protect them, and memory can actually cause them not to work. So just be cognizant of that. And then .NET framework, of course, is required to run to .NET. Next. All right, so this is just kind of a continuation. New tricks, old platforms. Really, it's not a one-trick pony, though. Just be understanding of that. And then a lot of business apps are a real big thing today. We talked about that too. How many people work with managed security or work with as MSP for managed services for IT? Okay, so we got 1, 2, okay. So how many times do you have a customer or client that's like, hey, I've got this thing in my environment, I don't know what it does, it's a pop-up window, it's annoying, can you just turn it off? Right? Okay, yeah, all the time with that. So, and people generally just disable it. Michael's going to show you in the demo, though, like what you can do to actually not just nuke EMET, but to use it more effectively. And then you can, of course, opt into all its functions for every single critical protection. Thanks. All right, so the mitigations. We're going to focus on the ROP stuff. Pretty much, the demo is self-explanatory. If this is like a higher level of like computer science stuff or whatever, then please go back, check them all out. There's not going to ever be a shortcut with them. If you're going to start working with them and using it effectively and correctly, you need to understand and take the time to do the homework basically on all of these security controls. We're not saying that you got to go dig in the weeds and understand how memory works and how we've written everything at the operating system level. You just need to know kind of the functional use of each one of these protections. So of course, when we're talking about ROP stuff like collar checks, like I said earlier, we're making sure that these critically protected functions aren't being called in from other libraries and stuff that aren't relevant to where it should actually be executing from. Looking at symexec flow. Symexec flow is kind of cool because what it does is it's actually going to run through the process of execution steps a couple of times. So think about looking into the future slide. Okay, let me see where this is going. Bam, bam, bam. Okay, it really shouldn't be getting called as a jump and return off the stack, which are obviously commands to move memory around. So, and then a little library check is really cool. That happens a lot with LLC. People try to start pulling hackers, right? So they'll write these exploits to try to start pulling things out of memory that comes from all sorts of other applications. You've got like something like Windows Update running in the background. It's got these really cool gadgets, which are little short pieces of code in memory that's already loaded from some other process, a legitimate function, and you're trying to attack a certain process. So they try to reach out there and say, hey, I want you to go ahead and load in something that I can use that's a legitimate item in memory for Windows right now, and it shouldn't think that this is irregular. So don't really worry so much about what's on the left side. I mean, you have to understand all these, but for the talk, you should be fine pretty much navigating to the right side. Next. All right, so risk to using EMET. A lot of people tend to forget that there are some nuances with it. Of course, if I start wrapping some of your memory, the way it was coded or programmed, you may use functions from other places. One of the things is the commands that are issued instead of using callers, checks, or trying to use jump or return. It can also cause your application to crash. And then production environment, I think it's pretty self-explanatory. I want to put on the slide because it's more of an operational control. But of course, EMET, it is good. It can be GPO deployed and things and set up and configured remotely. But do not just start pushing it out. Please always test EMET. Put it on the control box. Play around with it a bit, and then get your config file up and running. And then SSL pinning, don't really depend on it right now. They're working on it to become a little more robust, where users can be a little bit more in control of what to pin and not pin. Thanks. All right, so there's real issues. I'm going to try to blow through this quickly a little bit. Basically, in the past, EMET's had a bunch of problems, okay? We set EMET up, yeah, it is what it is. It doesn't protect itself back in EMET 4. So EMET 4 we kind of had this rise of issues. Blue Hat Challenge was issued. Microsoft had their own conference and said, hey, so we're throwing EMET out there, we're going to have a challenge. And whoever thinks that they can actually, exploit memory that's being protected by EMET or an application, we want to know why, and we're going to give out a prize. I mean, yay, so that's cool, right? There were some really creative ideas that came out of that. So basically, in a nutshell, EMET works by wrapping, hooking the application running. So EMET DLL will actually go and inject itself as a DLL injection, which is exactly kind of how a lot of attacks work today. So it injects itself almost like malware, and which is running across the memory, and it does some things with that memory and the process involved in it. So in 4.1, people decided that they were going to do some really cool stuff to kind of own it. But anyways, WoW64 is one of the big issues that we have today when running it at a hypervised layer for 64-bit compliancy. Running 32-bit applications at a 64-bit layer with EMET right now will cause a lot of issues because EMET doesn't have the 64-bit protections yet enabled for WoW64 fully developed. So just note that. That's important because a lot of browsers today, I think the last year there was a survey saying about 80% of browsers were actually running 32-bit on a 64-bit hypervised layer. And it was like, hey, I'm protecting this. But none of my controls work because they're all coded for 32-bit and you're hypervising at 64. So be careful with that. Next. All right, so blasting through this a little bit more. Several folks and groups of men have found ways to defeat it. Blue Hat. We're going to talk really quick about Birmingham Labs, Jared DeMont, and OffSec. Next. All right, so in a nutshell, I'll caveat this pretty simple. Jared DeMont was a really smart person because he said, hey, I'm going to take and I'm going to attack every single critical control that EMET can provide you as far as protection. So every single one of its mitigation techniques, Jared and they were like, well, let's see how we can defeat these things. They came up with some pretty good ideas about using stuff that's already there, how we can get around bypassing some things. We can avoid color checks. We can get around EAF by pulling in import tables instead of export. If you aren't real big on memory, how that works, in a nutshell, we're going to use what's already out there running in the average Windows environment in memory and start playing around with some of that stuff to see what we can get around and bypass. Next. All right, so Jared figured out that he can get some return-oriented programming code actually running and working. And basically Jared was like, hey, I can take the stuff that's out there, I can actually write my own custom shell codes. One thing about EMET is EMET will pawn most Metasploit interpreter shells right out the gate. Because the reason is a lot of them actually depend on using return and jump functions, as well as calling into, they call gadgets from other processes that are listed as critically protected on the export table. So by default, EMET can stop those autonomously. But Jared figured out if he custom hand writes some things, basically pulls stuff that's out there, he can get by it. Next. And that's basically explaining the same thing. Jared just assumed that attacker has control over a trigger. You're going to be using Internet Explorer 8, 9. Jared, I believe it was 9 actually. And he basically said, okay, I know it's a legitimate instance, it has Internet Explorer 9 running in it, and I know that has a memory protection. So I don't have to do that research. Hackers don't either, right? So as defensive people, we need to be understanding a little bit about what the vulnerabilities are out there right now actively for the software we're deploying. So Jared did exactly that. And knowing that as an offensive guy, he could basically pick it apart because there's a lot of information on it. And then environmental controls, he wrote his own little tools basically. Next. All right, so caller checks. We talked about this a little bit, just making sure that it's not, it's using legitimate calls, it's not using returns and jumps from all over the memory stack, coming from all over the place, because obviously organized, proper code normally doesn't do these things, which Metasploit tends to, obviously jump all over. Next. And then we talked about load library, just make sure that it's not loading in a DLL from somewhere that's already sitting on the heap and saying, hey, I'm here, but I'm not really normally using this process. Jared was able to find a way to pull in something that you normally do use to make it look like it's legitimate. And kind of walk right through the gate. Next. And then, obviously, this is this little cool thing that you've been phoned. He put that in there basically because he came in second place for the Blue Hat Challenge to another gentleman. Microsoft didn't actually put Jared's research into their improvements. They put the other guys, and Jared came back in the next version and phoned it. Next. All right, so talk about mem, sim, exec, stack pivot, and EAF. Memory protect, basically we talked about that, making sure that certain legitimate calls aren't coming from marked stack pages. That's only read-only, I'm going to make this read-write. Interpreter likes to do that when it migrates processes and things like that. It's looking for that kind of stuff, basically. And then sim exec flows, where it's actually flowing in from, it runs a few instructions ahead and says, let me go try this out. Theoretically, bam, 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 if I call this, push that, do that, memory, okay, that's safe. It looks like I'm okay. Am I actually going to do a return and jump and just start writing into like a NOP sled on the stack? And then EAF is obviously the export table. These are legitimate. It's okay to export and pull these things out and use them. Next. All right, so in summary, basically, like I said, Jared was able to bypass all the controls using legitimate tools that were Microsoft. Microsoft returned basically saying something very important. EMET is not designed to be the be-all, end-all, process protections and a solution for even memory there. What it's designed to do is it's designed to make hackers have to work harder, develop more crafty, custom, complex ways of bypassing these controls and sneaking through the gate. And in a nutshell, it was a deterrent, which is a really good tool. So moving forward, think of EMET as a deterrent strategy. Next. All right, so then they said, try harder. This is OffSec. If you don't know OffSec. OffSec was like, hey, why don't we try harder? We're just going to go ahead and completely own EMET. Next. So basically, OffSec did this really cool thing where OffSec was like, hey, you know what? EMET's running. It's injecting itself just like an interpreter. We make those cool things in our distribution, and we maintain that with the Metal School project. So how does that work? Well, let's look at legitimate processes. So in a nutshell, EMET DLL injects itself, wraps itself around this process. Somewhere in memory, EMET's tracking that it's turned on. OffSec was able to find this offset value because it was statically set by Microsoft. Go in there, write the 0 out, link it out. In a nutshell, the global flag is now set that EMET's disabled on this process. So they didn't protect EMET itself. EMET's protections were protecting that process, but EMET DLL at the time wasn't protecting itself from these things as well. So that's 5. And then offset came along and said more EMET. All right. So anyways, we killed the EMETs. As I talked about, the global flag was written. It was read-writable instead of just read-only. So if you wrap yourself and protect it, set it to 1, someone that EMET is enabled in this process. However, they left that in a place in memory which is also writable. So offset said, okay, go find offset 0, and EMET goes bye-bye. Next. All right, and then they did a lot more cool stuff. And in a nutshell, basically, Microsoft said, hey, we're going to go ahead and make that protected because we're going to encode where the offset is. It's no longer static. We're going to move it around, and we're going to put a pointer to it that is encoded. Well, offset said, okay, why don't you just call it a decode pointer? We can find the pointer, we can decode it, using decode pointer, which is already included in Windows naturally. And now we know where to go wipe that global flag, and now it's turned off again. Next. All right, and they tried to hide it harder using another encoding scheme. You see the goals there. Here's how you see it. Microsoft is like, hey, we keep moving things around. Oh, you can't find our encoder, we'll find the pointer. Okay, we'll encode that again with a CPU ID. OffSec said, okay, fine. Why don't we just go ahead and find what EMET uses to find this itself, a natural process in EMET, and use EMET on itself to disable itself. Because the cool thing that, like sysadmins work at, like we talked about earlier, people just like to do this cool thing in EMET called turn off EMET. So what you do in the GUI, what you do in the command line all the time abusively, offset did in memory. Next. All right, so basically moving forward here, EMET 5.2 didn't really do too much to help that or whatever. We put a little more protections in place. We tried to hide these pointers a little bit more. It worked for a while, but not forever. EMET 5.5 came rather quickly after that anyways. Next. All right, so Microsoft didn't really change anything moving forward. They were like, hey, this is a bit tough, but you have to be cognizant of this because it's not meant to stop stuff, and people kept thinking that was what it's for. But in a nutshell, they tried to hide this pointer again, and another researcher came forward and said, okay, I'm going to find out how you hide it, I'm going to reverse that, and then I'm actually going to use EMET itself to disable itself through its natural function. Thanks. All right, so now Michael's going to go ahead and give the EMET demo. Basically, he's going to show you a walkthrough. I talked about logically what's going on. Michael's going to give you the actual hands-on here.
Okay, so basically, where's the overview at? So I'm going to go through, I'm going to show you what the UI looks like. I'm going to show you what the command line looks like. I'm going to use Meterpreter or Metasploit to do a psexec to the box. I'm going to migrate to a process that's not protected by EMET, and I'm going to protect that process, and then I'm going to migrate to it again and show you how EMET actually captures that. And then we'll talk about some of the local GPO, how to add local GPOs to it, and then show you from the command line how you can view some of the protections. Because from the GUI, you can't see group policy protections. You only can see group policy protections from the command line, and we'll go over that. All right, so let me switch. All right, you can see that, yeah. Can everybody see that fine? It's not cut off or anything, is it?
Yeah.
All right, so this is the main GUI. When you download and install EMET, this is what comes up. And there's some default applications that are protected. So like Office Suite, Internet Explorer, of course, basically your Microsoft core products. And then they have some profile files that are it's called your recommended software and popular software. So they added some more things in there for you that'll be protected. The best way to update those things are to add all the applications that you want to add to the software. Just come up here and click on Add Apps. It'll bring up this screen. Add application, you go through your directory, find whatever applications you want. So you can go to C drive, go down to program files, and let's say you want to protect, Google Chrome. Go here, Chrome, application, and you click on Chrome. It'll plug it in, and by default it selects everything except for a few things that may cause, an application to crash. If you look at it, I don't know if you can see it up there, but the ones in bold, those are the ones that are protected by default. Anything that's not in bold, it's things that you added to the software, if that makes sense. All right. John went over all these protections, so you can uncheck any one of these if you wanted to. DEP is one of the ones that you can't uncheck. That's enforced by Windows 7 by default. It's system-wide. You can't change that. But you can just go through and just uncheck different ones if you don't want to protect those. So what this means is if you add an application or you have an application that's crashing and you believe it's EMET because it didn't start crashing until you install EMET, go through and uncheck each protection one by one until you find the one that's causing the issue, and then re-enable the other ones. That way you're not disabling everything. Okay. If you want to change your the default profiles, it's right under here. You just click on Custom Security, Maximum, or Recommended. And these files are in the EMET directory. So if you navigate to the EMET directory, Program Files, EMET, if you go to Deployment, you've got your group policy and you've got your protection files. So these are your default files that come with EMET. All right. What you need to do with your group policy files, you copy these files in your Windows profile definitions, and then under the profile definitions you have your English US, and I'll show you that in a second. So that's your basic UI. Down at the bottom, you have these green check marks that let you know what processes are protected by EMET. So if you see the green check, that means EMET is protecting that process. If there's no check there, that means EMET's not protecting it. All right? It's basically EMET's version of your task list. So what we talked about earlier was anything that's being applied by group policy, you cannot see from this GUI. So when you look, when you go to your apps, right, this is basically what's protected by EMET right now. You will not find anything protected by group policy in this list. So if you're a sysadmin or you're responsible for configuring EMET in an enterprise environment, and you're wondering why all the applications that you spent 2-3 hours configuring aren't showing up on your client systems, that's why you have to actually go to the command line and view it from there. And from the command line, we'll just jump there. You type EMET_conf, you have to go from the directory, or if you configure your environment so you can run it from anywhere, and --list, you press enter, and it'll give you your entire list along with your GPO configured programs. So I went ahead and already configured these ahead of time, and that's why you see those two there. By default, obviously, there would be nothing there. If you're on a local computer and you want to modify your local GPO, obviously gpedit.msc, you'll pull up your editor, and you come into application configuration. You can see it's already enabled because I added those two. Come down to, so obviously it'll be not configured when you initially start it up. Go to enabled, click on show, and then you can just, in the value name section, you put the path. So you can put, C:, programs, whatever you want to put, or you can use a regular expression. You can say *, whatever. It's easier just to use *, in the name of the process, because you might have a typo in the path that you type in, or that application might be installed somewhere that's non-standard. The other thing is that's kind of a downfall to EMET is it works off the path that you give it a binary name. So if you protect Notepad or you protect Chrome and somebody changes the name of Chrome, it's not going to be protected. For some reason, they don't use hashes of the binaries that are in Windows or applications that are well known, which I think is something they probably should do, at least for the core Windows, like System32 binaries, right? Those should be at least checked by hash and not just by the path name or the name of the binary. So anything over on value is what protections you want to enable or disable. So you can do basically you can read everything on the left-hand side. So down here it gives you exactly what you need to configure that. All right, so we'll move on from there. If you want to verify that a process is being protected, use Process Hacker. Some of you probably use sysinternal's Process Explorer. You can do the same thing. I just prefer Process Hacker. Cool thing about Process Hacker is if you have if somebody creates a service on your box or does nasty things, Process Hacker will give you an alert that a service got created, service got deleted. So that's kind of why I like using it. And there's some other things that it does that Process Explorer doesn't do. So we'll check and see what processes we have protected. Right? We said we can come to the main screen and look at here, or we can do from the console. And so we see we have command.exe is protected, right? We also saw that at command line. Where is it in here? It's not in there. So let's add one. It's in the third one on top. Okay, yeah. So it's protected, right? So it's got all the default protections. So let's see where that DLL is. Let's find command.exe. Here it is. You go to properties in Process Hacker. Probably won't show it in modules. Let's do Notepad. That'd be a whole lot easier. I think Notepad is Notepad++. All right, so Notepad++. Where is it at? I don't see it. Oh, I'm not running it. There it is. Yeah, that would be a reason. All right, so if you do have the process running, click on Properties, go to Modules, and you can see it right there, EMET DLL. All right, so any process that you add to EMET and you want to verify that it's actually protecting that process, you can come in here and check it out that way. There's also another tool in sysinternal called List DLLs, or List Module, I think things called. That'll show you all the DLLs that are there. If you happen to run it and you don't see that DLL in there, it's probably because that process is already running. You're going to have to restart the process. That way you can add that protection. So if you add the binary to EMET while it's still running, it won't protect it. You have to restart that process. Okay? All right, so that's how you can verify that it's running. If it's a 64-bit process, same thing. You'll see an EMET64.dll. All right, only in EMET 5. The current version of EMET. All right. So now I'm going to show you a process that's not protected. I'm going to go to my other screen. And so I'm going to use, I'm already connected. And let's see, I might have to recreate the session. So I'm just using PSExec, nothing fancy. It's a standard tool. I'm just using Metasploit to do it. And if you PSExec to a box, EMET will not detect that. Right? It doesn't detect SQL injection. It doesn't detect you clicking on a binary that gives somebody a reverse shell. It detects things that are happening in memory to a process. All right. All right. So let's see. Oh, all right, we're already there. So let's find a process that's not being protected. Let's see. Or we can even create one. Let's see. So, Skill paint, yeah.
Hackers don't use paint anyways.
No.
It's always happening.
All right, so we'll run MS Paint again, and we'll double check that it's not being protected by EMET. And by the way, if I want to do that from the command line, I would just do EMET. I'll do delete, and then the path to MS Paint, right? Or I'll do just wildcard / just MS Paint *MS Paint. Same thing. You can delete everything, delete all. Another thing to note: if you delete an app from you can't delete an app from the command line. That's a group policy enabled application. So Discord and Notepad++ was added via group policy. You can't from the command line disable that. You have to use group policy to remove that. So that might be a consideration for using group policy versus just using the GUI. So anyway, I already removed that. We've got Paint running. We're going to check the. Going to use Process Hacker to see if it's actually disabled. So we've got MS Paint here, properties. We go to our modules. It's alphabetical. So we got EMET64 in there, so it's still protecting that. Did I click the right thing? MS Paint. Yep, it's MS Paint. Make sure I actually did turn that off. Oh, had to do OK. Refresh. Let's close that. Launch that. All right, so let's see. What's the PID for that? MS Paint. So we've got 6012 as the PID. We'll migrate. And so if it's any binary that's protected or process is protected by EMET, it'll pop up a little notification saying EAF protection detected, or whatever protection that stopped, it mitigated, and it'll basically terminate the process. So we can see we migrated successfully to that process. 6012, nothing happened, right? We can still move around, we can still do stuff. I can drop to a shell if I need to. You know, EMET's not triggering anything. Right now, this user has no clue that somebody is on that box. All right, so now we're going to protect. I'm going to turn the protection on while paint is still running and show you that it still doesn't protect it or detect that somebody's in that process. So we'll do it from the command line just to show you that you can do it from the command line for those of you that like the command line. So the command is set, not add, and then you can just do, you know, star / MS Paint. All right, do I have MS Paint already in there? Yeah, there's already MS Paint's already in there. All right. Let's do Notepad. I don't think Notepad's in there. Regular Notepad. All right, so when you add an application to EMET, it'll give you this little statement right here saying that you may need to restart it, which is what I talked about earlier. If you don't restart it, it's not protected, right? So we have Notepad running. We'll close it. Run it again. Well, I didn't want that to run. I've got mine set up so when I run Notepad, it runs Notepad++. All right, so we've got that running. Now when we come back over here, we'll see what PID that is for Notepad. And we've got 5716. Oh, let's get out of the shell first. That might help. All right, so while it's migrating, you see EMET just detected. EAF detected. EMET detected EAF mitigation, and we'll close the application notepad.exe. So that's what happens when you migrate, when you use an interpreter to migrate to another process that's protected by EMET. You'll get that notification. It'll terminate the process. The person's interpreter shell will crash. So it's still trying to migrate, but eventually it'll crash, my session will die, and life goes on. All right, on this end, several things happen. If you go to your event logger, all right, you'll see EMET will log it. So if you're doing remote login, this will get captured even if they wipe the logs. And anything that EMET triggers on will say EMET in it. So you can filter your logs for everything that says EMET. And it'll tell you exactly which process triggered. So if you look down here, you've got System32 MS Paint. Before that, it'll tell you that it was enabled. So this is when I added it. It'll give you all your default protections, everything that's enabled. So it's pretty detailed information for, you know, anything that you need to do for protections. Any questions so far? All right. So like I said, you have your group policy, your local group policy. These are all your configurations. You only get these settings once you copy those files I showed you into, and I'll show you the directory. So you take these files that's in your deployment folder. So you go to deployment, group policy, You copy each one of these, and then you go down to your Windows directory, right? Windows, and then you need to go to Profile Definitions. So the ADMX file goes in here, and then the other file goes into this directory. And then when you open up your local group policy editor, these configuration settings will be available. It'll be under Windows Components, EMET. Or you can do a search and look for everything that's EMET. All right. That's pretty much it. So that goes into our recommendations.
Yeah, let's go back to the slide. Yeah. All right, so it moved a little bit fast, but in essence, Michael went in there and did kind of what a common thing hackers do. That's okay. They tried to attempt it with an automated exploit tool, such as Metasploit, using something like Kali Linux. So as you noticed before Michael enabled EMET, you couldn't see anything, right? Everything's moving around, things are migrating. Just like that, though, using EMET, configured correctly, pushed out and fully managed right, we were able to see that in an export address table, mitigation was kicked in. There was a bit lock that was thrown, and obviously terminated that process to protect it. Okay.
I got one more thing to add. So this is the XML file for the recommended software that EMET comes with by default. So you have your Office suite. That's pretty much what it looks like. And then if you want to create your own custom file, so let's say you have an enterprise and you don't want to use group policy for some reason, and you just want to create a custom profile, this is what it looks like. You wouldn't do this by hand, so you're not going to just hack away at Notepad. You go to the application, you add every application you want on a test box, and then you export that. So if you go to EMET, you just do, there's a feature to export the current configuration. And then you can take that file and maybe you set up a share and have every other box pull from that share, or however you want to distribute that XML file. So that's also another option. You can do group policy. You can manually configure every single application. You can create a profile box and then export that and utilize that. Question?
So with the EMET configuration, is the EMET configuration file itself protected?
It's not any more protected than anything else in the program file directories.
Okay. So if, for instance, I wanted to attack an EMET implementation, if I just attacked the configuration file itself and corrupted the configuration file, wouldn't that corrupt the ability for EMET to?
So it reads the configuration file once it runs, and it doesn't keep rereading that file unless you restart or refresh it.
So say, for instance, I attack the configuration file directly, I just corrupt it and then remove the process.
Huh?
Yeah, so that's kind of an out-of-band thing. For EMET, you were saying methodology-wise, yeah, I'm sure that would have an impact, but that is a static file, it's flat, it's not protected, because EMET works against processes, remember.
Yeah, but if you're pushing it out through group policy, then you'd have to, just like anything else. But yeah, EMET runs as the user that's on that system. It doesn't run as system or any other user. It runs as that's the problem with a lot of these applications. If they run in the same user space, malware runs in the same user space. They're both competing, and obviously running EMET in kernel space is not a good idea, right? So that's the problems we have right now, which is going to lead to some of the recommendations that we have later.
Well, quick question, we'll go into recommendations.
Yeah, what reason why, most of my experience has most of the Microsoft Office products are Wi-Fi. EAF plus, you know why that is?
I didn't hear the question.
I'm sorry, can you speak up, please?
My experience, I've had mostly Microsoft Office products are the ones being blocked by EMET. Do you know why that is? It's usually like an EAF plus category. I'm having to go on down and just going away. Do you know why that is?
Which version of EMET are you running? Yeah, so they do admit that there's problems and conflicts, and that's why some things are off by default. But the current version should fix a lot of those problems. Are you running the current version of EMET?
Yeah.
Like which version are you running?
5.5.
Yeah, because they just updated it, patched it to 5.51 now.
How long ago was that?
I don't remember the exact date, but I know there was there's like a recent one of 5.51.
Okay.
So try that one, see if you have any problems, or just disable EAF. So it's not an end all be all. There's just different layers that the attacker has to go through, and having EMET is just, it's going to be way better than not having anything else. And like I said, if EAF is giving you that problem, just disable EAF.
Each one of those columns, I'm checking the box. I mean, that's still the simplest way to.
That's the Microsoft recommended way of of if you have an application that's a conflict with EMET, one by one disable them and see which one causes the problem, and just keep that one off and keep everything else on.
So just real quick, basically, we were going to talk about throwing up some bullets for research, looking at ways to basically help out. And Michael already said earlier, doing hash-based instead of path-based control schemes. So we don't want, to automatically protect EMET based on just the relative path or the actual path to a binary, right? Maybe we should look at doing a little more advanced things with hashing it. And then an extensive list of common exploited applications would be really cool. MSRC has some community groups trying to do this as well, kind of like crowdsourcing. Next. And then control flow enforcement technology, shadow stack. It's really cool looking into this. Ed and I, our ISA was awesome. If you're local, check it out. They had a gentleman came through and talked about the new Intel extensions and how they're going to use things working at the hardware layer to protect, the memory, obviously. Yeah. And then device guard credentialing based protections on memory.
Anybody heard of shadow stack?
Yeah.
All right, so there's nothing good?
Yeah, we're going to wrap it up. Any questions after this, Michael and I will be available as well, and you can catch us and we'll talk more about it. So hopefully we did accomplish the objective today, which is basically to help understand that EMET's not perfect, it's not an end-all be-all. At this time, it definitely has a lot of work that's going on right now. As we said, there's a bug, someone contributed to that. So look into it, learn it, and the better you use it properly, the more effective it'll be for playing this hide-and-seek game we're going to continue to go through, it looks like. We'll go into questions real quick. I got some giveaways on behalf of our guests and our great sponsors. Real quick, Southward's donated some lockpicks to the event. What is the current running version of EMET?
Oh.
Wow. Okay, quick hands. You guys are fast. No.
5.5.1.
Okay, awesome. And then, who was the Birmingham Labs researcher that competed and came in? Okay, that was way quick. Name? What's his name? Yes.
Get your hand up.
Jason?
No, next.
Jared?
Last name? Okay, I'll give it to you. Good job. Right. Michael.
Let's see. What's the name of the command line tool used to configure EMET? You already answered one. Yeah.
Oh, come on, be good.
Let's see. What's the name of the protection that EMET mitigated when I migrated from one process to the other? Yeah, you got it.
Okay, good job. So the last two prizes real quick for the sponsors as well for donating this. Thankfully, it's we had an alpha land USB adapter as well as a land turtle. So good job, everyone. And it's time, Phil.
Yeah, thanks, guys.
All right.
5 minutes.